All right, so this is the next lesson in Algebra 2. It is Unit 6, Lesson 6. It's called Analyzing the Graphs of Exponential and Logarithmic Functions. So a few definitions to start. The first definition is called an asymptote. Okay? An asymptote is a line that continually approaches a given curve but does not meet it at any finite distance. Exponential functions will have what's called a horizontal asymptote. They do not have any vertical asymptotes because x can have any value. So for example, let's say we have the exponential function, y equals 5 to the x power. You can use any x value you want, okay? So x's can have any value for exponential functions, but they are going to have a horizontal asymptote because they cannot have any y value possible, okay? There's a limit. And conversely, logarithmic functions will have what's called a vertical asymptote. Logarithmic functions are the inverses of exponential functions. Therefore, they do not have any horizontal asymptotes. Okay? So let's go through one of each type. Okay? Let's start with an exponential function. Okay? So this is an exponential function. It's labeled right there, but this is an exponential function. That means it's going to have a horizontal asymptote. Let me jot that down. And in this case, the asymptote is right here. This is the line that the graph is going to never actually touch. It's going to approach it, but it's never going to touch it. That's an asymptote. Now remember, the equation for a horizontal line is always y equals a number. And in this case, it's y equals 1. So let's jot that down. This asymptote is y equals 1. Okay. This next graph, this is an example of a logarithmic function. So let me jot that down. That means that it's going to have a vertical asymptote. Now remember, this thing in the parentheses, that's called the argument. So the argument must always be greater than or equal to 0. So if you think about it, what's the argument here? It's x minus 1. That has to be greater than 0. So when you add 1 to each side, that means x has to be greater than 1. And you can see that's true in the graph. Okay? So the asymptote here, it's a vertical asymptote. And the equation for a vertical line is always x equals a number. In this case, the number would be x equals 1. I'm going a little fast through this video. I'm a little upset because I just recorded it and it did not save. Again, the technology at North Kingston High School has abandoned me today, so hopefully this one records, but it's my second time doing it, and I already have a million other things to do this year for school, so I'm going a little fast today. Again, my first video did not save, of course. This next page should be all review. Recall that the domain of a function is the set of values of the independent variables for which the function is defined. Typically, this is the set of x values. And recall the range of a function is the complete set of all possible resulting values of the dependent variable after we have substituted the domain. Typically, this is a set of y values. Next comes the increasing and decreasing intervals. We've done these a lot this year. An increasing interval means as a function is increasing, x increases, reading from left to right, as y increases. So for example, this is an increasing interval. It's going uphill, the slope is positive. And this is an increasing interval. It's going uphill, the slope is positive. A function is decreasing if, as x increases, y decreases. So for example, this is a decreasing interval. Again, we've done these a lot this year. And I always have you write down these two facts whenever we do these. You're going to use the x values when you identify the increasing and increasing intervals. And you always use parentheses with these. The end behavior, we've also done a lot this year. The end behavior of a polynomial function is the behavior of the graph of f of x as x approaches positive infinity or negative infinity, or maybe a different number. It does not always approach positive and negative infinity, as you will see in the upcoming examples. Okay, example 1. For the graph below, state the asymptotes, the domain, the range, the increasing intervals, decreasing intervals, and end behavior. So the question is, does this have a horizontal asymptote or a vertical asymptote? And you might be confused. You might have trouble deciphering between the two. But I will tell you on the quiz whether it's an exponential function or a logarithmic function. So this one is an exponential function. I will tell you that on the quiz. That way you know if it's a vertical asymptote or a horizontal asymptote. So again, I'll tell you that piece of information on the quiz. This one is an exponential function, which means it's going to have a horizontal asymptote. So the asymptote is the line that the graph approaches but never actually touches. And I'm going to say that it's y equals 1. Remember, a horizontal line is y equals a number. So you may think that the graph actually touches 1 by looking at it. And I understand why you might think that, but this graph never actually touches 1. That thick arrow at the end might make you think it does, but this graph never actually touches 1. If you were to say that it does touch 1 and you wanted to say the asymptote is y equals 0, I'll understand that and I'll give you credit for that. And this one, the asymptote is y equals 1. The domain is the x values in the graph, which goes from negative infinity up to infinity. It's going to keep going to the left forever and to the right forever. So the domain is negative infinity to infinity. The range is the y values in this graph. If you look at the graph, the y values, they go from 1 up to infinity. Now, earlier in the year, I told you if the graph actually includes 1, you would put this symbol. But this graph does not actually touch 1, so we're not going to use this symbol for this one. You're going to use a parenthesis instead. So the range is going to be 1 to infinity. The increasing intervals means where is the graph going uphill? Where does it have a positive slope? And this one has a positive slope everywhere. So for the increasing intervals, I'll say negative infinity up to infinity. The decreasing intervals means where is the graph going downhill? Where does it have a negative slope? And there are no decreasing intervals here. So I'm going to say none. And the end behavior means what's happening at the two ends of the graphs. So what's happening as x approaches negative infinity and what's happening as x approaches infinity. The easy one first, as x approaches infinity, so as x gets bigger and bigger, the graph is going up, okay, towards infinity. As x approaches negative infinity, so as x gets smaller and smaller to the right, what number is the graph approaching? It's approaching negative 1. I mean, it's approaching positive 1, but it's never actually touching 1. That's the asymptote. So I'll say f of x approaches 1. Okay, next example. Example 2 is another exponential function. And again, I'll tell you that on the quiz. That way you know if it's a horizontal asymptote or a vertical asymptote, in case it's hard to tell. Oops, I should say exponential function, not exponential asymptote. 1 second. Okay, so the asymptote is going to be y equals negative 2. Again, if you think the graph actually touches negative 2 and you say the asymptote is y equals negative 3, I'll be okay with that. The domain is the x values in this graph. So the x values go to the left forever, very slowly, but they do go to the left forever, and they do go to the right forever. So the domain is negative infinity up to infinity. The range is the y values in this graph. The y values go from negative 2 up forever to infinity. So I'm going to write that like this, negative 2, because the smaller number comes first, up to infinity, parentheses around both. The increasing intervals means where is the graph going uphill? Where does it have a positive slope? There are no increasing intervals, so I'll put none. The decreasing intervals means where is the graph going downhill? Where does it have a negative slope? And that's everywhere on this graph. So I'll say negative infinity to infinity. And then the end behavior. What's happening as x approaches negative infinity? And what's happening as x approaches positive infinity? Well, as x approaches negative infinity, as x gets smaller and smaller, the graph is going up towards positive infinity. And as x gets bigger and bigger, and as x approaches infinity, the graph is approaching -2, the asymptote, but it's never actually touching -2, so that's my answer. Okay, 2 more examples. This next one is a logarithmic function. Again, I will tell you that on the quiz. That means it's going to have a vertical asymptote, which means the equation is going to be x equals a number. In this case, the asymptote is going to be x equals 1. Again, if you say the graph actually touches 1, you want to say the asymptote is x equals 0. I'll understand that. But the asymptote is x equals 1. The domain is the x values in this graph. So the x values in this graph go from 1 all the way up to infinity. Okay, 1 all the way up to infinity. Parenthesis because it's not actually touching 1. The range is the y values in this graph. So the y values in this graph, it's going to go down forever. And it's going to go up forever, very slowly, but this graph is going up forever. So it'll be negative infinity up to infinity. The increasing intervals means where is the graph going uphill? And it's everywhere, but you're using the x values, and the x values start at 1. So for remember that was on page 2. You use the x values for the intervals. So the increasing interval is going to be 1 up to infinity. Decreasing intervals means where is the graph going downhill, and there are none. And that leaves the end behavior. What's happening at the 2 ends of the graph? So one of them is going to be as x approaches infinity, like usual. But this graph never actually approaches negative infinity. So for my other end, I'm going to say what happens as x approaches 1, because that's the other end of the graph. So as x approaches 1, and as x approaches infinity. So as x approaches 1, the graph is approaching negative infinity. And as x approaches infinity, the graph is going to keep going up forever and approach infinity. So those will be my 2 end behaviors. All right, last example. Example 4. This is going to be another logarithmic function. And again, I'll tell you that on the quiz. That way you know if it's a horizontal asymptote or a vertical asymptote, but this one's going to be a logarithmic function. So that means we have a vertical asymptote. So this last one's going to be a logarithmic function. It's going to have a vertical asymptote, okay? And in this case, it's going to be -5. So I'll say x equals -5. That'll be my vertical asymptote. Domain is going to be the x values in this graph. So if you look at the graph, it's going from -5 up to infinity. And again, parentheses, because it's not actually including -5. The range will be the y values in this graph. So it's going to be going down forever and up forever, very slowly, but up forever. So range will be negative infinity to infinity. Increasing intervals means where is the graph going uphill? It's going uphill from -5 up to infinity. Decreasing intervals are where it's going downhill. where it has a negative slope, and there are none, so I'll say none. And finally, the end behavior, so I'll say as x approaches something, and as x approaches infinity. So the graph never actually approaches negative infinity for x. So I'll say as x approaches -5 will be my other end. Okay. So as x approaches -5, you can see the graph is going downhill and it's approaching negative infinity. As x approaches infinity, the graph is going uphill, so the graph is approaching infinity. Okay, so again, that can be tricky. With this one, the graph does not approach negative infinity for x. So as x approaches -5, the graph is approaching negative infinity. And as x approaches infinity, the graph is approaching infinity. Okay. Just got to rewrite that. It came out messy. Okay. So again, the next lesson, lesson 7, will be graphing these two types of functions, exponentials and logarithms. This lesson was just analyzing those graphs. So that's how you analyze those graphs.